Hello guys, so welcome back to our lectures. So in this video, we're gonna introduce you to assembly language. But before going into assembly, we're gonna know first the structure of a computer, what's inside the computer, basically, and what's the role of, the main component in a computer. Then we're gonna know how computer interact with instructions, how it perform arithmetic like addition or subtraction. Then we're gonna go to assembly language, because assembly means you write a code to process something, to add, to subtract, to move, something like this. So we need, and for this, the computer will use its components, its memory, its CPU, processor, basically. It will initiate addresses, it will use registers. So we must know first, all such components and their functions in order to understand what actually will be done when we write assembly coding. I'm gonna use today slides from my friend Dr. Qasim Khalil from Western Kentucky University. So let's start. So here is basically the outline of this lecture and the next lectures as well. First, we're gonna learn what's inside the computer, basically, the main components, what's the function of each one, how the CPU or the processor is dealing with such a component. Then we're gonna apply this to a specific architecture, which is our main focus of this course, which is 8088 or 8086 microprocessors, from which we're gonna learn, or their assembly language. Then the internal microprocessor itself. So we're gonna learn in the beginning, in the computer, the processor as a component and the surrounding. Then what's inside the processor exactly. Then finally, we're gonna introduce you to assembly programming. So let's start with what's inside the computer. Just a quick revision in the beginning. Bit, we know bit is just one bit in a binary number. Nibble is 4 bits, byte is 8 bits, word is 16 bit, but it depends on the architecture. So some architecture use 32 size as word, some others use 64. So we're gonna stick in this course to a word of 16 bits. Kilobyte is not 1000 bits, no, it's 2 to the power, not 1000 byte, it's 2 to the power 10, which is 1024 byte. Mega is just multiply this number, the kilo, by itself. So it's a kilo multiplied by kilo, so 2 to 20. Giga is 2 to 30. Tera is 2 to 40. This is just, some terminologies, like mega is usually have abbreviation, which is M. Gigabyte has abbreviation, which is G. Terabyte has abbreviation, which is T. And of course, kilo, which is the most, the most used terminology in this course, will be K. Inside the computer, you can find what's called RAM and ROM. So there are two main storage devices inside the computer, in any computer: RAM and ROM, random access memory, and ROM, read-only memory. The random access memory, it's very fast. It's much faster than the ROM, and it's used for read and write as well, but it's volatile. It's a volatile memory. I mean, when you turn off your computer, the data will just vanish, will be deleted automatically. So it only preserves the data if the computer is working. Otherwise, it will just lose, the data. ROM, it's read only. So most of the time, because some ROM, like flash memories, it's read and write, but it's faster than the ROM, but less fast, or slower than the RAM. ROM usually hold very important data, like like for example the time. So or some important information like the BIOS for the computer. So these data shouldn't be deleted at all times. So we store it inside a ROM. And as I said, it's non-volatile. Here is the main organization of many computers. You have a CPU, which is a processor itself. Then you have memory, which is just RAM and ROM, or maybe or both. And you have, peripherals like monitor, printer, whatever. So the CPU will communicate with these two components. Actually, they are not two, because there are we can say two main classifications, peripherals or memories. But inside each one, there are many devices. So the CPU will interact with anything connected to it using the address bus, using buses basically, address bus and data bus. So, roughly speaking, for example, if the CPU want to read something from the memory, it will put the address of this location in the memory on the address bus. And this address will be recognized by the memory. It will not be recognized by the peripheral here, because it's their address. And then the RAM or ROM will put the data on the address on the data bus, and the data will be read to the CPU. The CPU itself is a processor unit, central processing unit, which executes or processes, information stored in the memory, like making arithmetic operations or logic operations, store, read. So all these operations is done by the CPU. So the CPU controls everything. It's central processing unit, and also controlling, its peripheral and memory. That's why here the address bus is actually one way. I mean, it's only the CPU that put data on the address bus. Although the data bus is bidirectional. So the CPU can send data to the memory, for example, and they can receive data from memory or from, the peripherals here. As we said previously, there are the CPU communicate with its, connected devices using buses. We have address bus, we have data bus, and I introduced you the concept of each. And there is also what's called control bus. And also, roughly speaking, just a primary example, assume that we wanna read or write something to the memory. So in reading and writing, you have the same operation. You have the exactly same operation, except in one piece, just one simple change. So you put the address on the address bus of the location in which you wanna read from the memory. But then it will be read or write based on another control signal. Let's say a control signal like this. And this control signal, means read or write. If it's 1, for example, that means read. If it's 0, it will be write. Let's assume that we want to read. So we're going to put 1. So the memory will read. It's basically reading operation. So it will put the data inside this location into the address bus. Let's say we want to do a write. So we're going to put 0 here. Same with the address, but now the memory will receive data to write inside this memory location. As we said, for any device connected to the computer to be recognized by the computer, it must have an address, a unique address. So this address must be unique. You cannot just put any address and these addresses can interact. No, they must be unique. It's like a name for something. So to identify something, it must have a unique name. So basically, this is internal, operation here is that for the CPU to communicate with any device connected to it, it just puts the address of that device, and there is, a decoding circuit that is connected to this device, that and only one device with such address will recognize this address and respond to the request. Then the CPU will use, as I said, the data bus to get the address or to send the address. And the control signal here will define either it's a read or write operation. Of course, if the data bus is wider, then the process can, execute or do more processes or become faster, basically, or because it will carry more information into or out of the CPU or the memory, for example. So assume that you want to read, 16 bits, but your bus is only 8 bits. So you're gonna do this operation in two steps. If one step is 1 millisecond, for example, then you're gonna consume 2 milliseconds. But if the bus is 16 bits, you're gonna do it on one step only. So for 1 millisecond, you will have 1 millisecond operation, not 2. So of course, if you have wider buses and more buses, basically, you're gonna have more expensive CPU or a computer because it's faster. And as we said, data buses are bidirectional because it's used to send or receive data. But control bus are just unidirectional, and also address buses. As we said, address bus is unidirectional. Another important operation or characteristic of the address bus is that if you have more address bits, so the address bus is just some wires like this. So the more of these wires, the wider basically the bus, the more devices can be connected to the computer. Let's assume you have address bus of 2 wires only. That means the CPU can communicate to just 4 modules. Let's name them module 1, module 2, module 3, and module 4. And all of them are connected to the same bus here. So for example, this one will be 00, 01, 10, 11. Now, if you have a 5th module, you cannot connect to that system because it will not have a unique address, because 2 bits, 2 wires can carry 2 bits, and these 2 bits can have only 4 distinctive combinations or different combinations. If you have an extra module and you want to connect, you must increase the width of the address bus. So you must add an extra line here. So that you can connect your 5th or maybe 6 and 7 and 8 as well. So in that case, you can connect an extra module. Actually, you can connect more than extra module. You can put M6, M7, and M8 as well. Just 1 extra bit will double. So basically, the number of modules that you can connect is 2 to the power of x, and x here is the width of the address bus. How about if you have a memory, and this memory has, for example, let's say 10 locations. Each location must have a unique address. So if you have here 10 locations, and you have 6 modules, M1, M2, until M6. So you must have here 16 different addresses. So your address should have 4 bits, or X should be 4 here. So the CPU in that case must have a 4 bits address bus like this. And all modules should be connected to the 4 lines like this. Okay, guys. The RAM and ROM, you know, as we said, all the data in the computer must be stored in either RAM or the ROM. And both of them are called primary memory because they are fast. So faster than something else. What is this else basically? It is a disk. So there are three main storage in your computer. There is the RAM, there is the ROM, and there is the disk, the hard disk. But the hard disk is called secondary memory because it's very slow. So the fastest is RAM, faster than the ROM, and both are much faster than the disk. Although this is getting improved now because of the introduce of the SSD drive, which is very fast compared to the old, you know, hard disks. But still, they are still inferior, we can say, in speed than the RAM and ROM. So that's it, guys. We're gonna start next time from you know, what's actually happening when you execute an instruction in the computer. So stay tuned for next lecture. Bye bye.